We've undertaken a 6-year study in which we have systematically redated the key archaeological sites that have been excavated over the last 100 years across Europe, from Spain, from Gibraltar, all the way to the Near East, and up as far as the Black Sea in the Russian North Caucasus. And we have systematically dated archaeological bones that come from the layers in the sites where we find the last Mousterian, which is equivalent to the final Neanderthal stone tool industry in Europe. And when we look at all of the radiocarbon dates from more than 250 samples that we've dated, we can see a very interesting picture, which is that the Neanderthal basically disappears around 39,000 to 40,000 years ago. After that, no more Neanderthals. So that's the first main conclusion of the paper. Now what's interesting about this is that it overturns some interesting hypotheses regarding very late survival of Neanderthals. And invariably, these late surviving Neanderthals are identified on the basis of radiocarbon dates. We found that the radiocarbon dates that were originally done are actually unreliable. And when we've gone back to redate those samples, we found either that we can't get any collagen from the bones, which means that it's likely that the original date is plain wrong, or we've got dates that are much, much older because of the improved removal of contaminants. The other main conclusion from the paper is that we've also found that there seems to be a late survival of Neanderthals in different parts of Europe. And what we can imagine is that, almost like a mosaic, there are patches where Neanderthals seem to survive a little bit later, and anatomically modern humans who are coming into Europe are part of that overall mosaic. Contamination is a big problem for dating old material. So if, for example, we had a bone that was 50,000 years old, and it was contaminated with 1% modern carbon-14, that would make the date 7,000 years too young. And that's 1%. So that gives you an idea of the kind of effects that we would see if we were unable to remove this contaminating carbon. It's been probably the most significant challenge in dating Neanderthal extinction, which is what we're interested in this particular project. And now that we're using better techniques, the picture is becoming much more clear in terms of the process by which Neanderthals disappeared from Europe. Well, anything like this, any scientific result has to be tested by others, and that's what we're doing. We're publishing our data so that other people will have a look at it and subject it to scrutiny. We've got a new research grant funded by the European Research Council, and that's a 5-year project, and part of that is to extend the work that we've done into other parts of Eurasia, further into Russia and China and places like that. But we also want to continue to work in Western Europe to test our models further. We use Bayesian statistical modeling to incorporate archaeological information and the radiocarbon information together. And so we want to go back to some of the most important sites and add more data, get more samples, and try and refine our models further, and also to extend the geographical scope of the modeling work within Europe. Ultimately, our aim is to sort of create kind of movies which show, the arrival and the departure of different subspecies of humans across Europe at this time, and we've part way towards that. But there's still a lot more work that we can do to try and establish and confirm whether our initial result, which is this mosaic pattern, can be verified further, and what other patterns we might find once we do some more research. So it's essentially ongoing work.